This is Talk to Obn show. You're watching Obn Horn of Africa. Today I brought you a young Ethiopian who is majoring in pharmacogenomics and precision medicine in the US. A very warm welcome.
Thank you for having me. I appreciate
it.
All
right. Please introduce yourself for us, and in that regard, people get to know you.
Okay. My name is Lilu Terfa. I was born and raised in Addis. I went through elementary school and high school in Addis, and then upon graduating high school, I got sent to Alamaya University, the health services campus, which was, well, not health services, but health sciences campus, which was based in Harar at the time. So I went to Alamaya University and studied clinical public health, which in Amharic would be Tena Makonnen. And upon graduating from there, I worked at the university for about 2 years as a faculty member, both at the Health Science College and Medical College, and then also managed the clinic, which was based in the campus. Worked there for 2 years, and then did some searching and looking into, broaden the horizon and further my education. I got accepted to a university in the U.S., California University of Management and Services at that time, to study health service management with a subspecialty of public health. And so that's how I went to the U.S., and it's been a good 8.5 years now, and so I'm back.
All right. You're the first one who study pharmacogenomics and precision medicine. I have tried to research people who got that background in Ethiopia, and I found Lilu Terfa, the one and only one. What do you feel about it?
It's really humbling and exciting at the same time, I would have to say. I mean, I've always kind of been interested in genetics and biology. So going through high school, I was really interested in sciences, biology, and physics. I didn't really like chemistry as much, so I was trying to see how I can pick a program that I can be a part of, that I can contribute, and that I can enjoy. When I was in high school in 9th grade, I got the opportunity to work with the World Bank. I was part of a youth advisory group for the country director at that time, and that kind of exposed me to the health care system in Ethiopia. We did a research on HIV/AIDS, which was the time where it was peaking. That was like 2003 European calendar, 2002, 3, and 4. I worked at the World Bank from this is during the summers, of course. Okay. During the school year, I would go to school.
That time you were a high school student.
I was a high school student. I was in 9th grade.
What inspires you to do that?
I was always interested in health, and my mother, who raised us, was always working with women through different NGOs and governmental organizations as well. And so I wanted to kind of see what is the problem.
Is she a government employee?
Currently, no. She works with an orphanage. She's a country director for an orphanage.
So she has got that affiliation.
Yes. Yeah. She's all my life. She's worked in development, healthcare, and a little bit of women's gender-based issues. So I was exposed to that. She used to make me write up her reports and translate them to English or to Amharic, and vice versa, and pay me. So I had a bit of an incentive to kind of be acquainted with the field, and so I kind of also was very active in my school and doing a little bit of extracurricular activities. So I was sent from my high school at that time to represent that part of Ethiopia, and that Addis. There were a total of 21 students, 4 from regional governments, and the rest from Addis. And so we formed a youth advisory group for the country director at that time. And so we were really interested in what we were supposed to do was come together, learn about the different programs that the World Bank was supporting, which at that time one was HIV/AIDS and the battle against it. During that process, we learned about like such a gap between the people that are living with the virus and a lot of funding that we're getting, and there's like a miscommunication, and we were like, well, we want to be able to help, and we want to be able to advise the country director in what the people actually need, and like fill the gap between the government organizations, which at the time was HAPCO, and different NGOs and different anti-AIDS youth organizations. Mm-hmm. So we had a draft to the project proposal, we got the funding for it. So I was a part of like a youth-based information dissemination project for different high schools and different information sources to create awareness about the virus, as well as like for people that were living with the virus, where they can find help, where they can find medication and, you know, different things. And so that kind of gave me a little bit of, hey, like if I study public health, maybe I can help, you know, draft a policy that can help with the struggle that we have in the country.
You studied public health at Roma University, and you got graduated with 3.6 something GPA, right?
Yeah.
Then you admitted to a certain university abroad in US.
Yes.
Can you tell me the way out? That's through merit, or I mean, your family got paid for that?
It was absolutely through merit. I did apply to a lot of universities at the time because, like I said, I was thinking about, you know, the university that I was working for. My university had just bought a hospital. They just started a medical faculty. So I thought, hey, like if I, you know, get a master's in something administrative, then maybe I can run the hospital. That's the thought process that I had. So I applied for different universities abroad, and I got accepted to do the health service management with subspecialty of public health. And so that's how I got in that field.
Currently, you're studying pharmacogenomics and precision medicine.
In precision medicine, yes.
What does this deal about?
So pharmacogenomics is a part of precision medicine. So precision medicine is the broader umbrella under which pharmacogenomics falls in. There's the study of, you know, genetic data, and then there is protein. There are different subspecialties within precision medicine. What it deals with is, you know, the Western world and the US, they're kind of getting away from the one-size-fits-all approach in medicine. What does that mean? Well, it means, for example, if a patient has an MI, like myocardial infarction, or commonly known as heart attack, the common or the first line of drug is Coumadin or warfarin. But it's a nightmare to those patients on warfarin because there are so many different variations within patients that influence how people process the drug. And so a 5 milligram dose for on warfarin for me might work, but for you it might totally get you into toxicity a lot quicker. And so scientists and a lot of healthcare professionals and geneticists are getting into, well, how can we tailor make treatment options into an individual? And so where that comes in handy for us is that a lot of medications, when they're formulated, and they're formulated in the Western world, they didn't really account for Africa and or people of African descent. And so for me, that was a big gap. And I was like, wow, like if I study this and if I become a pioneer in Africa and Ethiopia, I can do a lot. Because for people that have like serious illnesses like cancer, you know, we just give them the first line regimen of chemotherapy, and you know, sometimes that does more harm than good for a patient because they don't process it well, or the toxicity is a lot greater than the benefit. And so it's getting into, pharmacogenomics is getting into how can I tailor make a treatment option available for a patient. It's targeted therapy. It's no longer, well, everybody gets the same medication, the same dose, the same everything. Because we're learning now in the science, there are a lot of variabilities, polymorphisms in the genomic makeup of a population. And then even with a population, my genomic makeup from yours, we're both Ethiopians, would be totally different. So how do we account for that variability? And
so the world has lost so many individuals because of lacking this knowledge, right?
Absolutely, absolutely. We're learning, we're still learning. Even in the US, it's a very new branch. There aren't a lot of universities that are teaching this. There aren't a lot of, even the job market is kind of new. So it's a lot of pharmaceutical companies that are interested in this. A lot of FDA and NIH research, groups that are interested in this because they're learning. For example, like I said, warfarin, even codeine. A lot of patients are dying because we don't know the effects of the variabilities in genetics, and so a lot of drugs are getting labeled. If you see a lot of like codeine and warfarin, and a lot of about 200 plus medications in the US now have a black box label where the physician has to know the genomic makeup of a patient before they prescribe that medication because it can be life-threatening. So I'm studying something very new, something very exciting. Even in the US, it's a very new field, and so the applications of it would be the future of medicine. You know what I mean? And it's not just one area, it affects a lot of different areas. Like I said, cancer genomics is its own thing. And then there's like other genomic areas where, it applies. Clinical genetics is another area where it applies. And so the applications of it could be wide as far as variety.
Can you tell us some of the applications of this?
Yeah, absolutely. So the other thing that is big in the US and is not too big in developing countries is genetic disorders. There are different mitochondrial disorders. There are different autoimmune diseases that are not that are completely different from infectious diseases. And so, one, we have to know the patient's genomic makeup, and then after we know,
it's all about his or her gene, right?
Her genes, exactly. Yeah. So once you genotype the patient, that gives you something, but that doesn't give you everything. So we're learning that genotype doesn't equate to phenotype, which is phenotype refers to how the genes are expressed. Even if you have a gene, doesn't necessarily mean you're going to have the disease. There are going to be different factors that affect your genes and cause you to express your genes, which means you would have the disease or maybe you would lack the disease. And so what are those factors? Nature versus nurture. Your environment is one. The different consumption of food, alcohol, a lot of things affect that. Lifestyle. It affects all of that. And so in the US, there are a lot of research organizations that are tackling different genetic disorders. As far as I remember, when I was practicing in Ethiopia, we didn't really necessarily have the infrastructure or the manpower to, genotype patients and see if they have autoimmune diseases or even genetic diseases. So there are a lot of things that we can bring from there.
Good, Lilo. So as I have said a while ago, you are the one and only in studying this and measuring this study, right?
Yes.
What's your plan
in the future?
Specifically in Ethiopia and elsewhere in Africa? Suppose, you might be the pioneer of a new pharmacogenomics field in the continent Africa and the country Ethiopia.
Well, I think I would have to, one, finish my studies and, become proficient in the field. And just because I'm proficient in the field doesn't necessarily mean that I'm going to be able to do everything and anything that's required to bring that over here. So my personal goal, and this is part of my statement, my personal statement for when I applied to the school is, if I could have a way that I can get a lot of the practitioners in Ethiopia and Africa to be acquainted with this field. There might be things that we can do right now, even though we don't have the infrastructure and we don't have the manpower, but we can be preparing ourselves for when we do, right? We don't have to sit and wait. It's all about a lot of data. So when you're working with genomic information, it's a lot of data. It's IT heavy and intensive coding and a lot of data management, statistical data management. And so, God willing, my hope would be to come back to Africa and in Ethiopia. And we have the AU, the headquarters of AU here. We can work with other organizations or other governments as well. Maybe through networking, have a way to kind of maybe pull that genetic data from different populations in different African countries and then have it readily available for when we have the technology to use that into healthcare and to be able to implement it into healthcare. We don't have to stick to the older way of doing things. It might be a little far-fetched today, but it won't be far-fetched in 3, 5 years or 10 years, who knows? And so my goal would be to have as many practitioners, healthcare providers as possible to be doing the grassroots work and to be kind of preparing in collecting data and kind of like doing, kind of surveilling the land scales, the land, what is the word? I'm going blank, but like the groundwork for the population so that we can have a tailor-made treatment option for our population because we do need it and it's critical that we do.
Okay. Most students who just study abroad never get back to their home country after finishing their academics.
Yeah.
What is your plan in that regard? Because some of them just look and seek a better job with good pay abroad. Because Ethiopia is poor, they're not supposed or they are not willing to come and serve their people.
Yeah. I think for me personally, that really gets old really quick. Okay. We do have one life. We're all given a chance to do what we can for, our country. First and foremost, if it wasn't for the culture, for the people, for the country, I wouldn't be where I am today. So I'm grateful and indebted to the country and to the people that made me who I am. So I certainly. Even though I understand the appeal of like, hey, you can have a good life, why bother with, Africa and the bureaucracy and the lack of manpower and resources? Well, if I don't do it, who is? Who is going to do it? And we're not going to always be poor. We're not always going to be the underdogs. There's going to come a time, and hopefully soon, where we're going to overcome our poverty. We're going to overcome our challenges, be it in, healthcare or politics or whatever. So I would personally love to be part of that change, play some small role. And so I'm very much I'm aware of a little bit of the brain bleed, but I don't believe that it's going to be our story. As a country, as a nation, we've overcome a lot more harsher things as a people. And so there are just hurdles in front of us like many other countries do. It's just going to be one of those things that we're going to have to get through together. And I think given the chance and the opportunity, a lot of Ethiopians would agree with me that are abroad, would agree with me that, there is no better place to be than home and to do something. Because in the Western world, I'm one of many pharmacogeneticists or specialists. But in Ethiopia, I might be the only one right now, but hopefully for not long. I don't want to be the only one. I want to have a lot more people skilled in the areas that we need to implement those changes.
You should get back to your home.
Absolutely.
Home sweet home.
That's okay. The plan.
Sure. So let's talk about your college experience. What are the major challenges you've been facing as a foreign student?
So for me, I would have to say the one thing that I struggled the most with is the lack of proficiency in these science-heavy subjects. I never learned about molecular biology. I never really delved into genetics. And so when I had to take my prerequisites to get into this program, it was tough. I had to work twice as much just to be on the same level as my colleagues. And so for anybody that's interested in doing something that's not, common in Ethiopia and or Africa, don't give up hope. You can still kind of look online. There are so many different materials available online for free. You can kind of get in there and learn about whatever it is that you're passionate about, because you'll never know when the time will come for you to have that opportunity and that shot. You want to be ready. And so I think for me, the biggest thing was that lack of proficiency in the major science, heavy classes. But one other thing that I can see with a lot of other international students in the US that are, in the same classes as I am, is language. Again, if you put your mind to it, you can accomplish anything and everything. And so I'd say, put your mind to it and work hard. Practice, practice, practice.
Appreciate it. Okay, we do have so many brothers and sisters who just desperate to go abroad and to pursue in their academics, but they didn't know the way out.
Yeah.
What would you like to recommend for that?
Well, I would say, get involved, get your hands dirty, work with different NGOs. They have volunteering opportunities. Do networking. Keep your eyes open. A lot of government organizations, as well as foreign government organizations, as well as different schools, do give out scholarships to a lot of African students. And so it's a matter of just looking and searching online and networking. For me, my teachers all the way from high school, my principal in high school, my physics teacher, I remember teacher Abidja, my principal Goitam, my university instructors that were somewhere from the US, somewhere from India. They were all very instrumental in their own way. They encouraged me to look abroad, gave me pointers, reviewed my essays when I wrote them. And so if you really put your mind to it, you can...
Let's talk about your essay that convinced the college board while you apply for US.
Yeah, so...
it was about what?
It was about the need... So this time around, you mean, right?
For
pharmacogenomics?
Yeah.
Yeah, it was about me wanting to, like I said, bridge the gap between all these pharmaceutical companies and government organizations that are working on pharmacogenomics and the precision medicine part of things, and the lack of diversity that they had. It wasn't by design, but when they're developing these drugs and medications and treatment options, they're basing it off of their population pool, which is predominantly Western European. So they really didn't account for people of African descent. So I'm like, that's a really good niche. There isn't a lot of information about the genomic makeup and variability within Africa. And I want to be the one to take that back to Africa and, see what we can do. And so that's, I think, what convinced him to admit me to the program.
Thank you.
In part.
What is the advantage of studying this pharmacogenomics as a field of study for the globe as a whole?
For the globe as a whole, so it does away with a lot of complications. For example, toxicity, adverse effects of different drugs, and then also misuse of drugs, because we're learning now, some patients have no enzymes that metabolize a particular medication, and they're still being prescribed those medications because the practitioners don't know the patient doesn't have that enzyme. And so it's you can give them that medication, but you'll never see the effects of that medication because the patient is not processing the medication properly. And so it will help us get into a more tailor-made, targeted treatment. And then also, instead of using even drugs, just regular drugs, we can use other like biologic delivery systems, like what we're doing with the COVID vaccine, or CRISPR-Cas9. There are so many different things we can do that would have less and less side effects for patients as a whole. And so it'll just focus on better quality of care for patients as a whole. So I really do believe that the whole medicine is evolving to that kind of an approach.
Okay, good. We do have Ethiopia has under quality healthcare service. It's really offending. Anyway, in what way should a government and the Ministry of Health work on it to boost up this old school trend?
It's really kind of tough to be, living in the US and recommending what the government should do. But for me, what I think could help is that, when I was definitely going through undergrad here and then even working, the main focus of the government and the health Ministry of Health in Ethiopia was quantity. We were trying to get as many health stations and health centers as possible throughout the country, which at that time was very crucial because we did have people that were still lacking vaccinations, kids dying from, different things that we should be preventing right now. And so we focused a lot on quantity, but I think it's also time for us to really focus on the quality of care. So that would mean to, be it like maybe even starting a program that focuses on better quality of care in oncology, cancer treatment centers, and just really working towards boosting and establishing a care system where patients are not just getting the suboptimal care, but really getting quality care and making it available. I'm sure we can work with different non-governmental organizations and governments as well. It would benefit the whole world, you know what I mean? It's not just for us too. So there's a lot of interest with a lot of pharmaceutical companies to get as much data as possible from different, especially Africa, because this is where it all started for mankind, scientifically speaking. And so I think the quality of care needs to grow, and this is one area.
So in what way are you going to work with Ministry of Health if you got a chance after completing your study?
Oh,
it's a very important question.
Yeah, it's loaded and it's very important. I think for me, where I would have to start would be getting a task force of some sort together, or the practitioners. Educating the general population, mass population, is going to take so much work. And it's not something that, as an individual, one person can do. It's bigger than one person. And so for me, I think it'll be, possibly working with my university there or other organizations to try and get as many practitioners here that are practicing, that know what we're lacking as a country, as a healthcare provider. And getting them acquainted with precision medicine, pharmacogenomics, and targeted treatment. And then we can kind of divide and conquer what we have as a challenge, because I absolutely can't do everything. I would need, say, a programmer, because a lot of the genetic data is managed through an open source. It's a lot of computer, programming and coding. It requires a lot of that. And then the pharmacy part's a lot of pharmacology knowledge. So I would need a pharmacologist.
So it's a kind of intersection between IT and medicine.
Exactly. It's the intersection between IT and medicine. And so it's cutting edge. So I would need a lot of people to help with the project, with the program that we will be able to implement.
I mean, how does a certain practitioner conduct this test? Can you tell me the application? Do you really, test on human being or?
Oh, so what you're asking me is, how does it apply? Like how do all of these different specialties come together to work on a pharmacogenomic problem?
No.
Oh.
It's all about the medication and gene correlation.
Yes.
You do that, right?
Yes.
In what way are you going, or in what way you apply the test?
Oh, okay. So, okay, I get it.
You got it?
Yeah, I got it. So, for example, if a patient, if I, as a practitioner, if I'm going to dose a patient, if I'm going to start somebody on warfarin, I would have to do a genomic test for them. I have to make sure I know the genomic makeup of their enzymes that do process warfarin. There are about 3 different enzymes that affect the process, the metabolism of warfarin in a patient. So I have to genotype the patient and say, oh, this patient is an ultra metabolizer of this drug, or it's a regular, like, normal metabolizer, or a poor metabolizer. If he or she is a poor metabolizer, then I'm going to have to do away with warfarin and find another drug that he or she can use, because if they're a poor metabolizer, they're not going to metabolize the drug, which would lead to a lot of toxicity, a lot of side effects, and or even like the drug not working, and them still having the risk of clotting. And so once you've genotyped them, there are different websites that you can use that have the data and the recommendation for you. If a patient is, a variant for this gene, for this enzyme, then you have to reduce the dose by 1/3. What's recommended for normal patients is reduced. Or if they're an ultra metabolizer, then you have to up the dose by 1/3 for that gene. And so there are a lot of things that have to come together before you start a patient with a warfarin dose. And that applies to a lot of, like I said, in the US, we have over 200 plus medications.
It has got variation for identical twins as well?
Absolutely. Well, identical twins, their genomic makeup is identical.
Yeah.
What's different about identical twins is the phenotype. It's not the genotype, it's the phenotype. How
what
they
is that
express.
Phenotype?
It's how they express their genes. That has a lot to do with lifestyle, with exercise, smoking, different things that affect your genes. So we've learned so far that your genes are not the whole story. Your genes are not everything. Your genes are a big part of who you are as a person.
What matters is a lifestyle too.
You're more than that. It's called epigenomics. So your genes can be influenced by a lot of your lifestyle choices. So you can turn on a gene, you can turn off a gene. We're using those techniques to even treat patients who you can, for example, if a patient has a cancerous tumor, where the cancer, because we all have cancer suppressor genes.
Really?
Yes.
Okay.
Everybody has a
Innately?
cancer tumor.
Innately?
Yes.
Yeah.
It's in everybody. So once in the US, you profile the genomic makeup of a tumor, you sequence it and you see the cancer suppressor gene within that cell is suppressed or turned off. You can target that and you can make it so that you turn on the cancer suppressor gene. So the patient can, whatever turned off that gene can start producing cancer suppressor genes on its own, so without having to go through a lot of chemotherapy. That's what we call targeted therapy. What is the patient, why did this disease come about? Why is the patient having this cancer? And then fighting that, whatever is going wrong in the gene expression. If it's a gene that's turned on and it needs to be turned off, you can target it so that the medication you're administering to the patient turns off that gene. Or if it's a gene that's turned off, it needs to be turned on, like the cancer suppressor gene, you can just turn it on. So with CRISPR-Cas9, the gene editing system is very, very precise and easy to do. So that's what we're getting into in the US and trying to use that to benefit different patients that have different kinds of genetic disorders or malignancies. And so it's exciting. It's exciting science.
So can we say so many people died because of lack of knowing this all?
Absolutely. When genomics or genetics as a science was emerging, a lot of scientists were just kind of trying everything and trying to see which one works. It's kind of like throwing the pasta on the wall and seeing if it sticks. And so for a lot of genetic disorders that was. And so a lot of patients, a lot of babies died because they would develop cancer. We didn't have the precision of delivering that gene editing capability into a patient because we didn't know how it all worked. But right now we're making so many progress into tailoring medication and treatment into a specific patient. The ages of trial and error and one size fits all are quickly becoming history, for good reason too.
Which one comes first, producing a medication tablet and testing the gene, or testing the gene later producing the medicine? Which one comes first?
So
you got it, right?
Yeah, I got it. So a lot of pharmaceutical companies, before, when they are developing medication, they do test the gene. They have to check the genomic makeup of a patient these days, especially for a lot of malignancy treatment, cancer treatment. They're doing that. That's
For
becoming
instance,
standard.
whenever I just get persistent headache, I just go to pharmaceutical and buy Panadol or whatever.
So drugs like that, they're very effective, and even the side effects are very minimal, that you don't necessarily need to genotype a patient. But drugs like...
So which kind of medicine need that test?
Drugs that have a very narrow therapeutic index, which means like they're very, very strong. Like they're very strong medications. If you, like warfarin is one.
Which, an illness which puts you between death and life.
Yeah, I mean,
For instance, cancer.
Cancer treatment is one.
Lung disease.
Lung,
Not that much.
Yeah, it depends on what it is. If it's a lung cancer, yes, but or genetic disorders.
Majorly cancer-related stuff.
Cancer-related stuff, and then also genetic disorders. There are a lot of genetic disorders, severe genetic disorders, like that would mess around with people's ability to breathe and ability, like for example, Down syndrome is one. Debilitating diseases.
What about autism stuff?
Yeah. They're studying that. I'm not very familiar with autism itself and what they're doing, but for example, Alzheimer's is one. Alzheimer's has a genetic makeup factor to it, and it's a dose-dependent disease, in that, like, if you have one mutated gene, because every patient or every person gets one copy of the gene from the parent, from the dad, and one copy of the gene from the mom. And so for Alzheimer's, late onset Alzheimer's, or even early onset Alzheimer's, there are two types of Alzheimer's, that they have a very significant genetic makeup to them, the disease. So if a patient has that genetic mutation, then what can you do for that patient? How can you prevent them from developing the disease so early? There are stuff like that, you know what I mean? Stuff that is really hard to treat. We're using a lot of genetic data and information to kind of come up with different medications to help and give them a better quality of life, and or even treat the disease as a whole.
Okay. Lilu Terfa, thank you for your precious time. Really appreciate you. Of course, you are having a vacation, and you have been exhaustively working on your academics abroad.
Yeah.
Thank you for being our guest today.
I appreciate it. Thank you.
All right. Dear viewers, you've been watching Talk to Obn show. Thank you for your time. Bye-bye.